How microchips are made inside a semiconductor factory. CPU manufacturing explained. These factories span the size of multiple football fields. Every modern device begins its life inside a semiconductor fabrication plant. Even a single dust particle can destroy billions of transistors.
Each wafer is the foundation of hundreds of powerful processors.
Inside, billions of structures exist at the nanometer scale. This invisible world powers everything we use.
A single processor contains multiple cores, memory controllers, and graphics engines.
Each core is divided into specialized functional blocks. Arithmetic operations are physically executed by transistor networks. Even the smallest unit contains tens of thousands of transistors. Above the transistors lie many layers of metal wiring. Vertical vias connect these layers into a 3D circuit. Modern CPUs use over a dozen metal layers. At the smallest scale lies the transistor. FinFETs provide precise control of electrical current. These structures are thousands of times smaller than a human hair. Microchips are built layer by layer through a repeating manufacturing cycle. A light-sensitive photoresist is applied using high-speed rotation. The wafer is gently heated to remove excess solvents.
Each photomask contains the exact blueprint of a chip layer.
Extreme ultraviolet light prints features just atoms wide. Advanced optics shrink the design before printing it. The process repeats across every chip on the wafer. Exposed regions are selectively removed. The remaining mask is hardened for processing. A nanoscopic stencil now defines the layer. A single processor requires dozens of unique masks. Etching removes material only where the mask allows.
High-energy plasma sculpts features at nanometer scale.
Etching stops with atomic-level accuracy.
The temporary mask is completely removed. Conductive metals are deposited onto the wafer. Copper forms the wiring that carries electrical signals. Barrier layers prevent metal diffusion. Excess metal must now be removed.
CMP polishes the wafer back to perfect flatness.
The surface is flattened to atomic precision. One complete metal interconnect layer is finished.
Transistors are formed during front-end fabrication.
Atoms are accelerated to extreme energies. Dopant atoms alter silicon's electrical behavior. Boron creates p-type regions in the silicon. Heat repairs the lattice and activator dopants.
Heat repairs the lattice and activates dopants.
Fin structures define modern transistor channels. A single transistor is now complete. This process is repeated billions of times.
Microscopic particles can destroy entire circuits.
Wafers are cleaned using ultra-pure water. Specialized chemicals remove organic residues. Nitrogen drying prevents watermarks. Metrology tools measure features with nanometer accuracy. Even tiny defects are carefully recorded. Data ensures every step stays within tolerance. Data ensures every step stays within tolerance. Clean wafers re-enter the fabrication cycle. The transistor foundation is now complete.
A single wafer spends months inside the fab.
The back end connects billions of transistors together. Insulating layers separate metal wiring. Vias create vertical electrical connections. Plasma etching drills nanoscopic vertical holes.
CMP prepares the surface for the next layer.
Local interconnects handle short-distance signals. Intermediate layers connect entire cores.
Global wiring spans the entire processor.
Modern chips contain over a dozen wiring layers. The chip's internal wiring is now complete. Precise routing ensures reliable signal timing. Once fabrication ends, every chip must be tested.
Electrical probes test each chip on the wafer.
Not every chip will meet specifications. Chips are sorted based on performance and functionality. Lasers separate the wafer into individual chips.
Each chip is carefully handled. The die is mounted onto a package substrate. Packaged processors undergo final testing.
The processor is now ready for use. Every microchip begins not in a factory, but in nature. Quartz is refined into ultra-pure silicon. The crystal is sliced into thin silicon wafers. Each wafer is polished to atomic flatness. $100 wafer becomes worth thousands. Microchip manufacturing powers the global economy. Billions of transistors make billions of decisions.
Microchips represent one of humanity's greatest achievements. Hidden from view, chips quietly power our world.
Future innovations depend on even smaller chips. From sand to silicon to intelligence.
This is how microchips are made.